Hi there, and welcome to our lecture on changes of matter. So our key ideas for this section: why is getting a haircut an example of a physical change? Why is baking bread an example of a chemical change? And how can mixtures and compounds be broken down? So to first address this first question, a physical change affects one or more properties of a substance without changing the identity of the substance. So we can define that as a change of matter from one form to another without a change in the chemical properties. So an example I used on a previous lecture was taking a piece of paper, and if I take that piece of paper and I crumple it up, it's still paper, right? I can unfold it. I know it's bent and folded, but it still acts as a piece of paper. You can still tell it's a piece of paper. So the physical changes do not change the substance identity. You can still tell it's paper. Some other examples include cutting, crushing, reshaping, changing the state. So anytime I change from a solid to a liquid to a gas, or a gas to a solid, anytime we're changing the state of matter, that's also physical change. The substance at the molecular level is still the same. So if I take water as an example and go from a gas to a liquid to a solid, it's still water at the molecular level. It's just changing the way it looks, just changing the way it is. Dissolving is also physical change. So I can put salt in water, I can put sugar in water, and I can still separate the sugar or salt out from the water. And we can tell that the salt or sugar is in there because it has the properties that it had before it went into the water. So we put salt in water, the water then tastes salty. To put sugar in water, the water then tastes sweet. So we can tell that the substance is still there and that it's just a physical change or a mixture because it still maintains its properties. So I can separate it out just by evaporating the water off and get the salt or sugar out of the liquid. Alright, so chemical changes. Our second question: why is baking bread an example of a chemical change? Well, a chemical change happens when two or more substances are changed into entirely new substances that have different properties. So we can define chemical change: a change that occurs when one or more substance changes into an entirely new substance with different properties. So if I took my paper example and then I decided to light it on fire, well, it turns to ash and you can't really tell that it was paper. You can tell something was burnt, but it's not the same at the molecular level. It's changed. Here's some other examples of chemical changes. On the left side of the screen here, we've got the chemical reaction that produces the pigments that give leaves their different colors. So in the fall, when we see these green leaves start to change orange to yellow to red, these are chemical changes that are taking place. Here in the middle, got an effervescent tablet. Sometimes you put these in your water and you drink it to help like an upset stomach or heartburn. What happens with this particular tablet, the citric acid and baking soda in them react to produce carbon dioxide. So these bubbles coming off are an evidence of chemical reaction. This is carbon dioxide that's coming off. And then the Statue of Liberty used to be copper color, so it used to look like a new shiny penny. But we've had a chemical reaction, a chemical process that has taken place, chemical change in that copper to turn it to this green color. So chemical changes do happen everywhere. So some other examples of chemical changes: burning a substance, when something rusts, it's a chemical change. When we digest our food, it's changing from what we knew it as food. And then decomposing. So when plant material breaks down over time, decomposing. And we get new substances that come about because of those things. And we can detect chemical changes because there's something that's changing. So change of color, change of smell, it fizzes, there's heat that's produced, there's a sound produced, or even light can be produced as well. So change of color with a chemical change is a little different than putting food coloring into a jar of water. So that just kind of changes the color of the water. It doesn't necessarily change color because something's happening on a molecular level. So we put red food coloring in water and it turns red. It's just a physical change. But a chemical change, for example, we can mix two chemicals, maybe clear chemicals, and then they turn yellow. Well, that's obviously something different. Something is happening there. And chemical changes cannot be reversed by physical changes. So it requires a chemical change to change a chemical change. So a chemical change requires a chemical means to change it back. So if we had water and we broke it down into the hydrogen and oxygen gas that makes it up, then we would have to do a chemical reaction to get the hydrogen and oxygen to basically turn back into water again. So on this slide, if we were to just take this candle, or if this is a piece of chalk, I'm not sure, but if we just break it, it's still that substance, it's just in two halves. But if we take this cake and mix the ingredients together that allow you to make the cake, and then put it in the oven and bake it, that's a chemical change. The egg, the flour, that stuff that went into this cake is not the same anymore. So that's a chemical change. We can break down mixtures and compounds. So how can we do that? Mixtures can be separated by physical changes, but compounds must be broken down by chemical changes. So we can separate mixtures physically. So an example of that would be separating salt water into its parts by heating it. So when the water evaporates, so we heat that sample, we evaporate the water off, we've got the salt that's left over. We can use something called distillation to heat a mixture whose components have different boiling points. The components that boil and evaporate first separate from the mixture. And we can use a centrifuge, which is that device that spins around in circles really fast. The mixture spins rapidly until the components separate out based on density. Some compounds can be broken down through chemical changes. So some examples, say we've got mercury 2 oxide, we heat that up. What happens then is it breaks down into mercury and oxygen. We can also pass current through melted table salt, and the elements sodium and chlorine can be produced. So these are chemical processes. When you open a bottle of soda, the carbonic acid in the soda breaks down into carbon dioxide and water. So this is where you get that fizzing that occurs when you open a soda. Those bubbles that are coming off is the carbon dioxide from the carbonic acid. So thanks for listening.